Good morning, everyone. Today we have the presentation of the group number 3 with the topic production process of organic textile ropes and fabrics. Now you can start your presentation.
Hello, we are the group number 3. We are Ruben Santos, Ron Benitez, and Carlos Villasís. So we're going to talk about the production process of organic textile ropes and fabrics. Okay, the project is present the manufacture of organic ropes and textile used for fishing. The company problem is the production, the low production and the high prices. So our client is San Oceanos. San Oceanos is a company that made FADs, FID, to make the optics of the IATTC. So this company is located in the Manta, Ecuador, Manta City. So what is a FAD? A FAD is like a bait, but used for the high volume fishing. So typically, it's used for fishing from industrial boats. So when we want to a high volume of fishing, we need to use the FIDs, fishing adding devices. Okay. So why this is important to make this project? So this project will to meet all the objectives of the EITTC. The EITTC is the organization that certificates all the companies to export the products like tuna and other fishing products. So where we are now, currently the industry is capable to make 100 FADs per week. Each FAD it's around $450, and most of the process is done by manually. So as you can see in this GIF, it's like they make all the FADs, FIDs. So what is the objective of the project? Okay, our objective is increase the production over the 200% per week, and reduce the price of to $300 per FAD, and obtain a budget of the implementation of the improvements. So where we are now, the current manufacturing process, now they make this manually. So at the beginning, they take the raw material and come in the manual combing machines, as you can see in this image. And then when the raw material is combed, they put it in the spinning machines. This is a single spinning machine. So the operator take the material and put it in the spinning machine, and the spinning machine makes the work like you can see in the GIF. It's very similar to this. So once the operator finishes it, all the coils are moved to the respective stations. So we had the 4 stations to make the materials and products to make a FID. So we have 4 stations, like the 1/8-inch rope, the 1/2-inch rope, the 1.5-inch rope, and the loom station. So once all the products are finished, they take the ropes and the looms to the assembly station, and they storage all the parts in a rack or in a storage. And a FAD is like you can see here how they make a pad. So now, Ronnie, go ahead.
Thank you very much, Albert. We'll start mentioning the machine used in the each process of the final prototype to carry out the management of the road. Next, initial line. Yeah, okay. Next, initial line, the first combine is machine LJ 25.4 with a capacity from 300 up to 7 kilograms per hour. The second combining machine is LJ 12 with a capacity of 300 to 700 kilograms per hour. For representing this machine, the combiner will have an set of time, but we get 90 seconds for each piece. For down line drawing machine, the model is BJ 19.5 with capacity from the 300 to 70 kilograms per hour, 4 kilowatts of power. Next. The after Q1 is the spinning machine are the model FW 24 gain a single season of liver finding with a cone range between 0.3 and 0.6 1,800 revolution per minute. And the power gain is 11 kilowatts per power. Next. Now, the after Q is the one machine with the from the model DL 250 that has a yarn size of 150 and 600 meter kilograms. The power requirement of the 1.5 kilowatts. Next. The rock machine, the rock making process, the rock making machine will be of 3 different types of rock diameters. For the 5 millimeters, we are going to use Minis M22 wide, with 70.5 kilowatts. For the 15 millimeter ropes, we are going to use the RMS M15, the capacity of the 15 meters per minute. Finally, for the 25.4 millimeter ropes, that is the RMS M76, and the whip power gain of 22 kilowatts. Next. The running machine, the running process, and the running process for the first possible step with a winding machine with a 2 PLF65 and the 1 kilometers. The long process, if the field machine another winder machine electron and the 200 meters for mid rates. And the final process, the personal require the products of each process and process to join then to produce the rope. In the flexing, combiner with the observer, they simulate the same assembling process. Is the next diapositive. Next. It's a high resolution prototype, and the next analysis economic. Thank you.
Well, here in the CapEx and OpEx investigation, part of the economics analysis, we found out that some of our CapEx will be obviously the machinery acquisition that is investment we're going to do, as well as a fabric and building the building for all the machinery, and some of the OpEx will be be the environmental permits and government permits, since those have to take an annual renewal, and we can see some of the other CapEx and OpEx that our project have. Obviously, we're going to need some spare parts that our machinery needs for its maintenance. Next slide, please. At the economics analysis, we found out that our production will grow up to almost 1,000 units per month, but like the investment is going to be done by the last part of the year, it is going to scale at that part, and we are going to get our increase in production gradually. So all our production increases is going to be seen in the next year. Next slide, please. In our financial study, we found out that our project have a really high share. This is because with the machinery implementation, we are going to be able to upscale our production very high, giving us a real big rate of return with a share of almost 70%. This is due because all of our demand is going to be, all our production is going to be taken by our demand because of some government regulations that explicit tells to use these kind of fats that are some biodegradable fats. We have as well the VPN. That's what we're going to have at the end of the investment. This is due in 5 years total, and it is going to be over $3.5 million. And this is our project. We are going to show the simulation now.
Give me 1 second. Can you see the simulation?
Yes, yes.
Hello?
Yes.
Okay. So at the first part, we have a 1.5 tunnels each 24 hours. So we have to manufacture about 100 parts per day. That is the objective. As we can see, not all the machines are working now because they need to wait the material to begin to work. So we can start the schedule of work of the first 5 machines, and then 1 hour later we can start of the second station of the yard machines, and 1 hour later we can start of the loom machines and road making machines to improve the efficiency of the process and reduce the pay, reduce the cost of the employers. After 4 hours, you can see all the combine machines are not working. So the operators in these machines can go to the other stations to help the other operators, or can go to the combiner, the last station. This is the assemble station to help the assemblers and keep doing something. So after 12 hours, we have about we had around 89 fats. As you can see in all this queue, we have material ropes, 1-inch ropes, a 1/2-inch ropes, and 50 millimeters ropes. And it's okay because the company wants to export these ropes to Spain, Belgium, Italy. They want to make this, and they say this is okay because they can take this material and sell this to other clients. So there are no problem here if we have a material at the final of the day. So the simulation of the all machines can meet all the goals that we want to do. Do you have any questions?
Okay, perfect. Hold me a second. Good morning. Today we have the presentation of the group number 9 with the topic reduction of returning of wire assembles for stepper motors due to the failures in the customizing process in a manufacturing enterprise. Now you can start your presentation.
Okay, good morning, teachers. We are group number 9 by Juan Carlos Yepes and Jose Patiño. And as you mentioned, our project is based on the reduction of returning of wire assemblies for stepper motors due to failures in the customizing process in a manufacturing enterprise. Well, we have the description. Our project is based on a paper research. So we have that the problem is settled in a city of Mexico, Tijuana, in a manufacturing enterprise in charge of customizing wires and assembles those wires in a stepper motors. So we have the steps of our problematic. First, we have that customers give a stepper motor to the manufacturer and they specify the wire length and color needed. Second, we have that the motor wires are cut in order to be able to replace with the customized wires. Then the connector units are assembled in the stepper motor. Then the customized wire are designed and manufactured by NC machines. Then we have that the wires are assembled in the stepper motor, and finally the stepper motor is delivered to the customers. In this research, we identify when the problem occurs. We have that 52% of the times these assembles are returned because the wires are inverted. We have that 15% of these assembles are returned because the motor is not correctly configured. 13% is because the motor is making some noise. 10% the stepper motor doesn't work. 6% the motor doesn't have the ID tag. And we have that 3% of these stepper motors are returned because they have the wrong wires length or size. Next. So the objectives of this project is to propose a system which can be able to reduce from 67 returns of assemblies to 9 returns as minimum, in order to satisfy the customer and improve time waste. Also, we are going to evaluate the project finally applying concept of IRR, NPV, and discounted payback.
Well, now the process to arrive to our solution was to generate some ideas through the tool of brainstorming and also this potential difficulty graphic. So we went through providing workers a list of well-detailed directions for the production and no other change to our final solution that was to automate almost all the process done by machines, but the supervision done by humans. And this has a high potential impact and a low potential difficulty. So it will have a great impact with less effort. Now, for the methodology, we try to implement this process just including all the machines in every part of the process, like receiving all the specifications from the customers in a HMI, and this information have to go to a PLC, which will be in charge of distributing all the information to each one of the machines. So, for example, a cutting machine will be in charge of cutting all the wires for the motors, and also will be in charge of selecting which colors those customers want to have in their final product. Also, a robotic arm will be in charge of welding the wires to the stepper motors. Also, we have included a new stage that wasn't included before, which is the quality control, which will help us to identify problems before being delivered to the customer. Also, before delivering the product to the customer, we have included a client opinion stage in which this client will meet with an expert from the enterprise in order to see if he is satisfied with the product. If the product does not pass the quality control or the client opinion stage, it will go to the remanufacturing station, in which some machines will be in charge of making some corrections, like the measures correction, colors corrections. Also, will be in charge of the wire order and to see if the ID tag is correct placed in the motor. Well, now this is just a process map that describes all the things that I have mentioned before in the last slide. So as you can see, the process goes everything as it was, but it includes the quality control, and then if it passes this test, it will go to the client, and if not, it will go to the remanufacturing stage. If the remanufacturing stage, we will pass it again to the client to see if he's satisfied, and after all is validated, it will be delivered to the client. Well, now I'm going to present the simulation, and my partner will explain it.
Yep. So for the construction of the model in FlexSim, we have the following components and technical characteristics. First, we have the customer specifications and return. This process begins with customers who have brought their motors for some reason, and they want to customize their motor cables with a respective color and length. So we can see that we have two objects of type resource, one that represents the cables that will be customized by the client, and another that indicates the motor returned by the clients. Then we have that each of the motor cables are stored in a QE type object with a capacity of 10,000 cables. In addition, the flow of cables have been separated by percentage, where 16.66% will be sent through each of the output ports. Then we have the customized wires, because the cables go through a customization process of both the color and length previously established by the user. Then we have the remove wires stage. From the motor QE, 3 processes are connected that represents the removal machines for the cable returned by the customers. Then we have the sort wires stage. Once the 6 processors that represents the customizing machines of the color and length already defined by the user, all the cables are ordered. So we have the sort wires processors. Then we have the weld wires with motors, because once the old cables of the motor returned by the customers have been removed, and at the same time the new cables have been customized with the specified color and size, the process of welding the new cables with the returned motor is carried out. So for this, we have 3 combiners that are used, in which it will be connected to the inputs, the QE, and the processors. Also, these new cables are that are already welded to the motor. They are stored in a QE that has a capacity of 1,000, and it will be connected to 3 processors that represents the quality control stage. For the quality control, the motor speed and torque is checked by the worker in charge of the quality control. And as my partner mentioned before, if everything meets the specifications, it will go to the client opinion. So we can see that we have 2 possible scenarios. The first scenario is that if the stepper motor already welded meets the specifications and pass the quality control. And we have another scenario that if the motor is defective and doesn't pass the quality control, it will go through the remanufacturing line. So then we have the client opinions. As I mentioned, if the motor pass the quality control, it will go to this stage, and if not, it will go to the remanufacturing line. Next. Here we have some results like the wire remotion states. We can see that this machine have a yield percentage of approximately 58.93. Also, next we have the results for the wire customization stations. As we can see, these machines have reduced the idle time, which means that this stage have a great utilization. Next, we have the sorting wire station results and the welding wire station. And next, finally, we have the quality control station results and the order and welding correction. And finally, we have the output, the desired output. As we can see, approximately 100 customized in 24 hours was reached.
Well, now we're going to go through the financial study. Now we're going to present to show that in. I can open it. Okay, here it is. Well, here we can see all the expenditures that we are going to make for the operational expenses and the capital expenses. I'm not going to go too deeply into this, but this is all well detailed with all the costs that it implies. Now, to get the annual profit, we have to consider the revenues. We have considered a price of our service of $27, and considering 100 orders in one day for 65 days of the year, we have these revenues, but these revenues is just the raw revenues. We have to consider the cost of goods sold, which are the ones that consider the operational expenditures, which sum up this quantity right here. Finally, the annual profit is $102,575, and this would be our cash flow with we're going to consider our cash flow with depreciation. It means this value over here, and we have all the criteria. The present net value is more than 0, which means that our service is profitable. Also, we have that our internal rate of return is 36%, and we have calculated 2 paybacks, the payback and also the discounted payback. This payback is considering that we are doing the investment, so we have no worry about the TIO, and the discounted payback is considering that we have investors, so we have to pay a TIO, and we will have to give money to them in every part of each year. So for the discounted payback, we have 3 years and 2 months. Now, for the conclusions, we have that with the proposed system, with remanufacturing, 97 of 105 customers are served, which means 92% of them receive their products and 8% are waiting for their motor, probably because of repairs. Theoretically, with this system, returns are null. This could be validated only applying it in the real life. And finally, the financial indicators state the project is profitable and competitive. That's all. Thank you so much.
Good morning. Today we will have the presentation of the group number 20 with the topic cardboard manufacturing and printing. Now you can start your presentation.
Hi, I'm John Barberi. I'm going to talk about our project, about this flexible manufacturing system. And it consists about a cardboard company named Soluciones de Empaques. Soluciones de Empaques is actually struggling to keep their market share due to the delays in production. This is because they are increasing the number of clients that they have, so they are having a hard time to keep up with the production. Procarsa is the actual market share competitor in Ecuador that has the majority of shares. And the independent printing companies, the struggle that they have to gain an equal market share is that they need a dedicated production lines that they lack of. So our objectives for Soluciones de Empaques is analyze and design a flexible manufacturing system that can be integrated and allows to significantly improve the performance of the current manufacturing system of the cardboard production process. Our secondary objective is to increase their productivity at least by 15%, and also to compare the obtained results in the simulation with the actual production lines that they have at the moment. So this is the warehouse at the moment of Soluciones de Empaques. So this process consists of a corrugator, the combiners, the cutters, and also the operators in the printing process. We're going to show you the simulation so you can see what we're talking about. So our actual problem is that this is a cardboard company that prints for their customers. So we have a paper source. Can you confirm me that you can still see the simulation?
Yes.
Yeah, okay. So the actual problem is, okay, we have the corrugator, the paper enters, and we have a combiner that combines 3 slices of paper and produces a cardboard. So we have an operator, a cutter, and the cutter cuts the paper, and then it goes to a printer, a single printer in black and white, and then a printer that goes to dual printing, so in color. So we can see they lack queues at the end of these lines, so they have to wait until it is already packed to follow the next process. Then we have a pallet that combines the product, and an operator has to walk almost 20 meters to the rack so they can store the product. So what's the problem with this actual design? They are having delays in production and clients are not receiving their orders, so they're losing customers. We can see if we run the simulation, at the end of the day, they have only 7 pallets, but here are without combining the dual printing and the single printing. So in reality, they have only about 4 customers with their necessities met at the end of the day. So Guillermo is going to talk about what are the warehouse proposal so we can improve.
Hi. Our proposal of the process for this project includes the redistribution of loads in the employees assigning. It includes the redistribution of the loads in the employees. So then we assign them strategically in the flow, and in the first part of the flow. Then we can observe that the queues were added to the output of the printers to be able to collect the materials and distribute them for their respective process, either single printed designed or double printed designed. After combining the cardboard with the pallet, and then we have another queue that allows the process not to be stopped waiting for the automated guided vehicle that it's implemented in case it is busy. Okay. Yes, according to the simulation, with our proposed model, we can see that we have a better flow within the process. Queue times are improved, and the load on the operators is better than distributed, and the problem of product logistics to the racks is solved. Yes, actually, that's the part that I was talking about. That we can see that with this proposal, we have a better flow inside the warehouse. We improved all the queues inside the flow, and we can observe that we have a better working excitement at the first part, as doesn't have to be transporting the material to the racks. Also, there's an AGV investment that is going to carry that work of transporting the final product and storing them in the racks. That it will be the logistic of the process.
For the financing study, we have here the OPEX and CAPEX investment. For CAPEX, we will have an automate guide vehicle. This is an investment in acquisition of asset because there is not an actual vehicle at the moment in the company. The cost of the vehicle is $11,000. And also we will add 2 cube buffer zone. This buffer zone needs to be in some kind of platform in order to keep producing and stacking util. They are ready for the next production state. This cost approximately $1,600. For a total, we have the total of CAPEX is $2,600. For OPEX, the AGV or automated guide vehicle will need maintenance. Employees need introduction to learn how to operate in an environment where an AGV is involved. And also an expert employee needs to be appointed to oversee its maintenance schedule. This costs approximately $2,400. And also we need the personal capacitation. Workers need to adapt to the new buffer zone and how to adapt to the new FMS applied to keep productivity to the maximum possible. This costs approximately $1,350, obtaining an OPEX total of $3,750. The next. We have a total investment of $16,350 value obtained by adding the CAPEX and the OPEX. Using the formula, we obtain a rescue value of $3,604 with $4. The useful life expected of the AGV is 5 years. For the taxes, we search that all Ecuadorian companies must pay 22% tax on their worldwide incomes. The annual profit that we have is that the company have is $7,000, and with the formula also we obtain the depreciation that is $2,549 with 10 cents. The opportunity interest ratio or TIO of the company is 25%. Next. Here we have the cash flow without depreciation and with depreciation. Without depreciation, we have an annual profit of $7,000. The annual profit without taxes is the same that the annual profit, and the taxes that we obtain the taxes multiplying the annual profit taxes with the 22%, obtaining $1,540. And for the annual cash flow without depreciation, we subtract the taxes from the annual profit without taxes. Something occurs, similar occurs with the depreciation, only subtracting the depreciation that we obtain with the formula. Obtaining annual cash flow with depreciation of $6,020 with 80 cents. The next. Okay. The VPN is a more reliable indicator when evaluating a business or project. In this table, we can see that we have the present value in 5 years. we obtain with the formula that we need a TO that is 22%. When calculating the VPN for our project using the formula, considering a minimum rate of return or TIO of 25%, sorry, with an investment of $16,350 and having an annual profit of $7,000, we obtain a net present value or VPN of 2,474 with 96 cents, which being greater than 0, that is an indicator of viability of the investment of this project. The next. Also, we obtain the trigger, that is an indicator that allows measuring and determining the viability of an investment or a project in terms of profitability or profit. When calculating the internal rate of return, TIA or TIR, it obtained 32.22%, which is 7.22% higher than the TIO established by the company. So we can say that it is profitable. Next. Here we have the payback table where we use for the annual payback, the cash flow, that is the annual profit in each year from the year 1 to the year 5. We see that we will recover the value in 2 years and 4 months. Because as we can see in the table, we have negative values in the 3rd years. That means that in the 2nd years, approximately, and some months, in this case 4 months, we recover the value. The next. For the discount value, we use for the annual payback the BP, the present value or BP. That's the reason that in this discount that is more realistic, because we put the annual profit in 1 year. We will recover the value in 3 years with approximately 11 months.
Okay. As we can see, the implementation of this project will have the productivity of the plant increased by 25%. The company will recover its investment plus profits as shown in the finance study. Also, we will have the workers equally distributed in the process, and there will be more space to receive other customers or meet higher demands.
So that's our presentation. We're ready for your questions. And so as we can see, let's slow down a bit. Come on. So we have operator 1 on the cutter, and operator 3 we have on both printers, which also give us the operator 3 almost doing all the work, and the operator 2 also has a lot of other, although it's not a lot of work during the day, he has excessive weight to carry all the way to the rack during the day, so he can get tired during this process. So the main thing that Guillermo was mentioning, that our proposal includes these queues, so they don't have to wait until they can carry the pallets to the rack, because we have an AGV that will be able to do it. So we can see once again, the AGV can anytime when the pallet is ready, take it down to the rack. And we have almost 5 clients that their needs are met during the day. And in the other simulation, at the warehouse at the moment, we can see that they're almost, we have seven pallets, but in this model, they don't combine the dual printing and the single printed ones. So actually we have only 4 customers here with the necessities met. We have 1 customer, 2 customers, 3 and 4 customers. So that's why we improved productivity almost by 25% for clients versus 5 clients during the day. Any questions?
Good morning, everyone. Today we have the presentation of the group number 2 with the topic dry pet food manufacturing process. Now you can start your presentation.
Well, hello everyone. We are the group number 2, and well, the interns are Melissa Banchon, Cristian Quinteros, and myself, Luis Sanchez. Next. So, if we're talking about the dried pet food manufacturing process, we need to have this background. So let's start. For the number of pets in the world in the 2017, there were 670 million pets in the world, and we estimate that, well, it's estimated that at the end of the 2022, we will have 730 million pets, which this growth will happen, the 40% of this growth will happen in Latin America. And the market growth for the 2018 with the pet food industry was valued at $83.2 billion currently, or after all the changes that have occurred to the past to 2020. It is expected that by 2025 the industry will see a compound annual growth rate of 4.5%. So by 2025 the industry will be expected to reach the $90.4 billion. And the packaging facts that states that a growth pattern sales growth are expected to be 5.5% in 2021 and 2022, followed by 5% in 2023 and 2024. Next. So, given this background, we have the common problems in the pet industry. First one is the milling. In the milling process, we add some ingredients to make a mix to make the product. And if we have to be very careful. We have to be very careful with the time, with the milling time and the measurements, because if we fail in one of these, the product will not have the quality that we expect. And the second problem is the cooling. We need some big machines to do the cooling, and if we don't have enough machines to do the process, we will have a bottleneck on the batch. And the third one is the storage. I think this is a very common problem in every industry. We have the long storage time and logistic problems if we don't have a very good storage system. Next. And understanding the consumer tendencies. We know that in the society that we live now, everybody loves pets. It's a fact. We're all old people, young people, kids. And if we focus on the young people, they take pets as a responsibility. If they take pets as responsibility, they buy premium food. This food will be this food has to have the correct amount of nutrients for the pet. If we produce this premium food, the sales will be increased, and if the sales will be increased, it means that the productions will be challenged. And next. Given this, we have the sympathy map. For start, the think and feel. If the sales grow, the industry will need to cover this increase. So if they need to cover this increase, they will need to purchase new equipment to meet this new demand. What they hear is the fact that I said before that the industry is expected to be valued at $90.4 million by the end of the 2025. They see that the greater awareness of the importance of animal welfare and health. They say and do that the 5.5% increase in sales, the pet food industry must cover this shortfall. And one of the pains that the industry has is the possible bottlenecks, and the gains that they have is the possible increase in earnings to cover the new demand. Next. So now that we have talked about the empathy map, we need to talk about the user experience map in the process. We know that the pursuit material, preconditioning, extrusion, quantity, coding, and packaging are processes that don't give us any problems, so we don't consider it in the improvement of this system that we are talking about. But milling, drying, cooling, and storage are so important, and these are the most parts. In this part, there are the most failures, so that's where we're gonna focus our project. Next.
Okay, so now we have the manufacturing process. For this process, we have a stage with two secondary stages. For the first one, we have the preparation, that is the receipt of materials. That is all the ingredients we need to make those pet food. For the second one, we have the milling, that is done by a crusher machine. Next, we have the preconditioning, which is done with a mixer that adds water to this flour made in the previous process, and the extrusion cooking, where the dough is cooked in the extruder machine. This small stage here is about a quality process that is done in this part of the process. Then we have the next step, that is the drying, done with a dryer machine. Then it gets a coating, then the cooling, and finally the packaging. And there is another quality process here. For the low resolution prototype, we have the steps for the process. So here you can see like a back process. This means that the machine needs to continue doing its process till it's completely done. Here we have the simulation. As I said before, there is the crusher that takes all the ingredients, the mixer that makes a flour, extruder machine that makes a dough, and it cooks. Then the quality, then it gets dried, the flavor roller that puts some flavor enhancers, the cooling machine, and finally the packaging. As we can see, there's some difference in the production by those two processes. In the actual one, in an 8-hour workday, we have 212 packages, and in the improved one, we have 444 packages at the end of the day. It's important to know that in the improved one, we changed to machines, because in the dryer machine, there is a bottleneck when in the actual process. And when this was so the solution for the dryer machine, then the bottleneck was in the cooling process. So those two machines were replaced.
Good morning. I am going to talk about the cost of the project. In this table, the cost of the different machines of the project are represented. In the part left, you have the cost of the machine from when they were acquired. The quantity and the total of the investment for this machine, as we can see, the total cost is the 18,800. In the other part, in the right part, there are expenses of acquiring to the new machine to eliminate the queue and increase the production. Besides, there are also to the maintenance cost of each machine. The annual machine cost is the 130, and the total cost of the acquiring to the new machine is the 500. Next, please. One the expense are obtained, we calculate the general expense of the process as well as the income of the company. For income, we have the company will manufacture 250 bag of the food weekly, working 5 days a week, which are 8-hour shift. Each bag will be sold to the customer to a price to $9, and therefore the total income of the factory will be $500 Among the expense that the company has, there are expenses for electricity, water, transportation, advertising, salaries, among others, so that in the end, the profit of the company subtracting expenses is the $2,635. Next, please. As mentioned above, the profit of the company is $2,635, taking into account that the machine has 3 years of their life and the internal rate of opportunity of the 10%. Then the net present value and the future value we are calculating. For the first row, there is an ideal condition where there is not depreciation, and for the second row, there is in real condition. It is observed that the gain in the real condition decreases over time, that is due to the depreciation of money. Secondly, we calculate the net present value of which was $519 and the internal rate of return, which was 46%. This in contrast to the internal rate of opportunity, we conclude that we exceed the expectative of the investor. Next, please. Finally, in this table, we have important data for the project, such as the investment made both for the machine already acquired, as well as the machine that will be acquired as price, depreciation, year of the life, or investment for the machine. Then we make the accounting book, where for the first moment and the year 0, because because it is an investment, the company present a loss equal to the initial investment of the two new machine. And there are 3 years of useful life for the machine. The cost of the machine must be paid in those 3 years. So for the 3rd year, the comic book must mark $0, and I can be seen in the table. Finally, in the last row, represent of the depreciation of the machine. For the second table, we calculate the annual recovery considering the depreciation of the machine in the 3 years. Finally, in the third table, the first row represents the value of the profit obtained from the previous table. The second row represents the accumulated profit of the previous year. And the third row, Natalia, please. Finally, in the third table, the first row represents the value of the profit obtained from the previous table. The second row represents the accumulated profit of the previous year. And the third row represents the value of the recovery. It is observed that for the second year, this is already a profit sign for the second year. So the cost of the investment has already been paid. So the payback is 2 years. Next.
Good morning, everyone. Today we have the presentation of the group number 14 with the topic improve time and efficiency in line manufacturing for the extraction, packaging, and transport sub-process. Now you can start your presentation. You can start.
Andrea?
Sorry, teacher, do I have internet problems?
Ok.
Well.
Me avisan cuando estén listos, ¿ok?
Hola, perdón, es que se me fue el internet, disculpe. Okay. Okay, good morning. We're group 14, and our project is about improving time and efficiency in line manufacturing for the extraction, packaging, and transport to processes. That's the hint. Next. Okay. First, some background. Ecuador is an Andean country that is rich in mountainous regions, and from some of those regions we can get the limestone. Limestone is a type of carbonate rock, which is the main resource for producing quicklime, or also called calcium oxide. So according to a study made in a company called Incoret, which is a quicklime company that is located in Riobamba, they have an annual production of 50 tons of calcium oxide destined just for commercialization. Okay, so this report shows that production quantities are not enough to supply the demand of these products, since the quicklime has a high demand in metallurgical industry. And also they decided to increase its annual production to 80 tons and 40 tons of calcium oxide and 40 tons of calcium hydroxide. Next one. So our main problematic lies in the packaging process, which is time consuming and costly due to the numbers of workers required for that process. It is a process that is done manually. It takes at least 2 people just to fill the bag, a single bag with tools, shovels in this case, and it takes another one just to seal it. And also to move the bag to a pallet location, a worker also must carry it manually. So currently, companies such as Morocco and also quicklime company and Incoret are both suffering these losses of production. Next one. Okay, so our general objective is to improve the efficiency and productivity of at least 20% of the packaging and transformation process of lime, and in the calcium oxide manufacturing industry, by applying a flexible manufacturing system technology to generate a higher productivity, causing an increase of the profit of this material in the industrial sector. So for a specific objective, we got that some of them generate a higher percent of sales of lime, and also leading to an annual profit result of 30% higher than the result obtained in 2021. Also reduce the packaging time of the line compared to the time obtained in 2021, and increase the productivity and higher daily sales of the type of this product. Also, we want to generate a flexible manufacturing model that will reduce at least 20% the time spent in the extraction, packaging, and transportation of the final product compared to the rustic model that they already have. And also, we want to eliminate the possible risk to the safety of the personnel. Next one. Okay. For the primary and secondary research, we got some experience and observations. So we got there is frequent damage to the actuators that are in that industry due to environmental conditions, high repair costs. Also, the bagging process needs a group of at least 5 people, and also the use of rudimentary tools like shovels and those just to carry the bags to the pallet. Next one. Okay, now we got the empathy map. I'm going to tell some for the line manufacturers. What do they feel? What do they think? They feel pressure. They feel fear. They feel fear if the process will be more efficient using a manufacturing system. They see that a high labor cost. What they say or what they do, they provide endless working hours to workers. They also see or do efficient budget for the system upgrades. What do they hear? They hear that the competition is also innovating with this kind of system, and their pain, their pain is not having a lot of reference of this new system in the country, and their gain is acquired suitable machinery for a flexible system. Next one. Okay, so the user experience map. We got in the negative part that the budget estimate for the flexible system implementation. Also, we got in the positive side that application of the flexible system in the manufacturing plant and batch increase. Next one. Okay, finally, our research, we made a research about the lime manufacturing process, which begins with the lime, and we made like a flow map that goes from the extraction, the crushing of the rock, the separation, calcination, cooling, then the inspection, the crushing and pulverization, sieving, the hydration to obtain the calcium oxide, and then the final process, which is the packaging and the palletizing. Next one.
Now, the theoretical framework and methodology. First of all, after our analysis, we noticed that the problem was in the extraction, packing, interpretation process. And for that reason, we generate some solution. That is, for example, for extraction, we want to put a bevel conveyor in order to transport the raw material to silo. Going to be a crushing process. For packing, we want to implement a semi-automatic system that consists of a machine that have a pneumatic driving. This pneumatic driving going to fix the bag, put the materials in the bag, measure the pound of the bag, and then sauce the bag. All this in the same station. And for transportation is going to be a roll conveyor that's going to transport the bag that come from the packing process.
This is our low resolution prototype. As you can see the schematic of the machine and the schematic of the position that we want to put each conveyor. We select this machine because this machine gives us the capacity that we want. As you can see, it have a great accuracy, so we can put the material here. For this machine, we define two operators. One to put the bag in the mouth of the machine, and another one to switch the mouth of the bag in order that machine can sweep it. We calculate some metrics for this machine. For the packing part, we calculate a setup time of 3 seconds, and the process time will be 18 seconds. The sweep part, 1 second for prepare and 2 seconds for sweeping. You can see that before implementing the machine, the 12 operators only can produce 2 tons per hour, but with this machine we can produce 6 tons per hour. The meters for the conveyors, this velocity 1 meter per second, and 10 bag, only 10 bag, like maximum amount of bags. For the mean time to prepare and mean time to between failure, we focus in the damage of the actuators that are in this type of environment firm. The mean time to repair is the time that the people take to replace the motors, and the other time is the time that the motors damage. The first failure, we want to put a exponential distribution in order to get a random failure. Some aspect before the simulation. In the simulation, you're going to see some spheres. This sphere represents 30 kilograms. The cube going to have a space for 30 fair, and one pallet has 24 bags. This is the distribution for the raw material. Another important note of this project is that we are not able to measure all the time of each process of the plant. So we make our own statistics, watching videos that have not some edits. So we take time in that way, and the distance between the machines are no considerable parameter here. We have here the simulation, as you can see, of the plant. We are simulating a journey of 16 hours. We're going to here you can see the damage of the machine. So we have to wait 2 hours in order to replace. Here there's another damage. Then after the damage, we can see the plant that is working as well as we expect. This is our result. In a journey of 16 hours, we have this quantity. This quantity is in pallet. So we have 27 pallets, for example, in the small size limestone stone. But what happened? The time of journey is not the total time to the production capacity. So we simulate 4 hours in order to get that result and rest them, because the 4 hours represent the launch time, the introduction time, and some problems that are in the company. This is our analysis, some metrics. We are going to search the information about the transportation, because there are machines that cost a lot the repair. We can see the backhoe is the major the transport that work more, and the other one have many idle time.
In concert to the economic analysis, next one. Yeah, we got the stakeholders, which are the parties that have interest in the company and can either affect or be affected by the business. In this case, we got the line micro enterprises, the technicians and engineers, the workers, the final product consumers company, such as steel mills, mining companies, agricultural companies, among others, and machinery and software companies and environmental entities. Next. For the case of the OPEX, which are the expenses of the business that incurs through its normal business operation, we got the annual machinery maintenance, the maintenance of conveyor drives, the motor maintenance, the energy consumption. Next one. In the case of the CapEx, which are the funds used by the company to acquire, upgrade, and maintain the physical assets, we got the purchase of automatic packing and stitching machines, the purchase of design selected conveyor belts and rollers, the purchase of software for control and intercombination for machinery, and hiring of trained personnel for assembly and calibration of the machinery. Next. In concern for the cash flow, we made some considerations. Through our investigation, we make the result that the sewing machine that we're proposing costs around $50,000, and we're needing 3 of these machines. So we take in account those price, and the average price of installation is gonna be $5,000. We're gonna implement 3 cylindrical conveyors, so their costs are gonna be $750 and 1 conveyor belt. Here we can see our quantity produced calculation, the capital inflow calculation, the machine costs, which are gonna consider the all the 3 machines in our raw value, and the annual profit, which are gonna be the capital inflow multiplied to 3 times, because we are needing 3 machines, minus the machine cost and the other costs we got that we can see in the next slide. Next. Yeah, as we see here on the first table, we're gonna calculate the total investment value, where we consider the quantity of the purchases we're making. On the second table, we're considering the total depreciation value. And with this data, we're establishing the other tables. In the income table, we can see that our bags produced per year are gonna be 10,000, sorry. And our bag price are gonna be $3.50. The number of stations we're working with are gonna be 3 sewing machines. So we obtain the annual income of 23,688, and there we got our data table that resumes these all values for calculating the cash flow with depreciation and without depreciation. Next one. Yeah, in concern to the finance study, we had taken into account the other calculations we made for the first row of the cash flows, which are gonna be our annual profits. In this case, we're establishing a TO of 50%. So as we can see in the results, we got a tier of 18%, around 80%. So we can establish that our project is gonna be competitive because it's higher than the tier. Next one. And in the case of the net present value, we can see that we're making a profit because it's higher than 0. So our project is gonna be profitable. And in the case of the calculations for the BP, we are considering just the depreciation. So it's gonna be the annual income, the annual profit minus the depreciation. Next one. For the discount payment, we have into account the volume books, which are gonna be the investment value minus the accumulated depreciation that we also calculate in an Excel document. For a payback, we're gonna take into account the annual payback, which are gonna be the cash flows calculated before without depreciation, the accumulated payback, which are gonna be the sum for each year of these cash flows, the recovery value, which are gonna be the investment value minus the accumulated payback until we get a negative value. And for this one, for the first cash flow, without considering the present values, we have that the project is gonna be profitable on 2 years and 8 months. And in the case of the current paybacks, where we consider the cash flows as the present value, so we got that it's gonna be profitable on 3 years. We're gonna get back our investment in 3 years and 7.90 months. Next one. And here we got the conclusions. First one, we got a packaging and staging and transportation system was integrated that applies to all production lines. So it's possible to have a flexible system that allows customers to adapt according to market demands, since its more specific product is needed. Another packaging station can be used without the need for any significant configuration in parallel, and since the times used by the workers are low. The second one is by placing the new automated system in the areas. In addition to some modifications with respect to the conveyor belts, it can be inferred that the level of safety for the company personnel has increased because the personnel have just to be on supervision for the machines and not being involved on lifting all those bags. For the third one, we got it's concluded that the cost reduction exceeds 30%, as could be observed in the calculation of metrics. The salary cost is reduced from 12 people to 2 people, which are the ones that are going to be operating the machines for sewing and bagging, and the cost of electricity. For the last conclusion, we got that it is concluded that the project with the allocated data can be classified as competitive and enumerate since the investor can have profit since our net present value is positive. In addition to the fact that the tier is going to be 18.59%, which exceeds the TO and makes it profitable and competitive. Thanks.
Good morning, everyone. Today we have the presentation of the group number 15 with the topic application of flexible manufacturing systems focused on the cookie manufacturing process of Grupo Superior in Ecuador. Now you can start your presentation.
Okay, good morning, everyone. This group is composed of Gustavo Alvarado, Guillermo Castillo, and Alexander Maicela. Next, please. Okay, the objectives for this project, the general objective is improve the automatization system of the packing sub-process within the production line of the Ecuadorian cookie fabrication process using flexible manufacturing process in order to make to the manufacturing quality and product delivery time optional. The specific objective, the first is decrease the time of the cooking packaging process through the generation of design thinking, solution ideas. The next is approximate amount of monetary investment of the project to be proposed in order to establish in feasibility in conjunction with the cash flow and other data of interest. And the last is identify the amount of machinery and sub-process in the cookie manufacturing plant to develop a proper simulation that resembles to the real plant. Okay, the beneficiary of the project is Grupo Superior S.A. with its start product Salticas cookie. Okay, the description is this research project deals with Grupo Superior S.A. and Ecuadorian industry located in Guayabamba, Quito. This industry started in 1963 with the flour business until it researched the cookie and snack business, being the cookie area one of the most important. For the production of cookies, this process begins by processing the within a mill to obtain flour, with it is manually transporting a container car for the cookie production plant and the dough plant. Inside the cookie production plant, the minor inputs are wait spheres for the laminate and die coat cookie technology, so that the colorants, flavoring, and living agents. Then the major inputs such as flour, water, invert sugar, fat, and oil. After that, in the next area, the minor and major inputs are manually added in the mixer, and the results on the first flow, where this new throw in float by machines and placed one up on top of the other, so that the final product becomes crunchy. Then it goes through limiting a roller and finally through die cutting machines. Regarding the cookies salticas, the baking process lasts 2.5 to 4 minutes. Finally, the cookies are manually placed in machine to be packaged and sealed, and then manually processed in a box for distributions to national stores. Okay. My partner is the problem.
As I was talking, the problem that we have here is that despite all the technology that this instrument, that the industry implements in the cookie fabrication system, there is a part of the process that still needs one or more operative humans that delivers the package from one cell to the next cells that made boxing. This here leads to a lower production, a lower productivity, and doesn't let that this line can produce or excel his production speed. So how we approach to this problem, how we solve it? Well, we use the methodology, call it the design thinking. For this methodology, we use something that is called the empathy map that we can see in this slide. Involves asking to the worker, in this case, the worker that makes the packaging, we asking how they feel, what they see, how they think, and other things. As you can see here, one of the things that he can see is that he has raw material called indulge. He has a lot of new product machinery. He has a lot of different type of cookies that he needs to deliver properly in his own packages and in their own boxes. Besides that, he hears that the company is one of the most consumed around him in the territory. Yeah. He thinks that his work is really important to the company and it needs to be really well done, because if not, it can be really complex mistakes here. Well, one of the things that he suffers in this job is that he needs to maintain the cleanliness in his work study, in his work area, I'm sorry. And for that, he gains the salary and the benefits of the law. Well, after that, we have the user experience map. With this map, we use we ask to the worker how he feels about this cookie processing system. In this case, when he asked him about the mixing time and the wire cutting and all the things that happens before him, he responds with neutral answers, which means that he really don't have a former think about that. But when we ask him about his own process, he thinks that it's a really expensive, a really tight problem because he needs to put a lot of work in it. Besides that, he thinks that if he have help from a machine, he would be very happy about that. For the last, with all this information, we gather ideas to make this work. We put it in the difficult impact matrix. In this matrix, we put it in the right upper side, the ideas that has the more impact and that are the less costs of these ideas. So for this problem solution, we used the robotic arms. Thank you.
Okay. For the next part of the design thinking methodology, we made a low resolution prototype. As we can see a diagram with a proposed robotic arm solution, which will be located in the subprocess of packaging packs of cookies. And we can see that this robotic arm will pick up more packages than an operator could. Then for the high resolution prototype is the simulation that we made on Flexim, and we can see that later. Then for the finance studies, we have initial values as the investment value, rescue value, the useful life of the robotic arm, the annual profit, the taxes, and the TIO. And we had a result of a BPM greater than 0. So this means that the investment in the robotic arm will be beneficial to the company after 10 years lifespan of the robot. However, it is worth mentioning that the purpose of this project is to improve the production time in a given sub-process. In this case, the cookie packaging, but not to improve the company's economic profits. Now, with respect to the tier, this was found to be higher than the TIO, which means that the project is profitable for the investors. And finally, the discounted payback in this case means that taking into consideration the accumulated BPM values, the company will recover the invest value in 6 years. So now, in conclusions, through the application of design thinking, it was possible to obtain a better perspective of the company in order to arrive at a viable solution. The robot lowers transport operative time between packaging process about 22%, which can be used to increase the productivity in the cookies wrapping system. The use of the robot obeys the line of the production design, provides almost 0% of losses due to misplacement, low hygiene, or roach handling defects. And finally, the system has several points where there are room for improvement, starting with methods to arrange cookies after wire coding. And thank you.
Thank you.
We can see here the simulation that we made in Flexim. We have all the sub-process mentioned previously. So we can see that every in this case every 15 minutes a mass of flour arrives to the process, and then after every sub-process the cookies is made, and And we here on the sink, we obtain the final amount of boxes of cookies in a journey labor of 8 hours. So the final amount that we obtain in this case are 8 boxes in the 8-hour journal. So that should be it in this case. Okay, and here we can see also the throughput per hour in the machine of the cookie wrapping, that is the one here. And the work process of the robotic arm that is right here.
Good morning, everyone. Today we have the presentation of the group number 18 with the topic decrease in production time by automated changing heads in the manufacture of PVC pipes. Now you can start your presentation.
Good morning. Our topic project is, as said, decrease in production time by automated change heads in the manufactured pipes. So we have our description of a problem. For description, we did a research of the company and what's the current situation of manufacturing PVC pipes. In the first part, we know that we have a water supply due to a large number of existing pipes in our world. It's necessary for some companies, it could be a small, large, or medium, to have all these products to connect pipes for warehouses or buildings. And also we saw there are different manual times to obtain different diameter parts. So in the manufacturing of this, they have like different head changes. So we can get like 6 inches for a pipe, or a half inches, 3 inches, and different kind of those. Also, the time that takes to the operator to change these diameters when it's a production. So sometimes they use like cranes, big cranes, to move these heads, and it will take maybe like 30 minutes sometimes in this changing. Also, we have our justification for the project. Our project needs exactly to reduce the production time with the implementation of this automatic equipment. So implemented like some parts of robotics and control systems. Our technical feasibility will be the application of industrial robots. So in the actual market, we have like different parts of different pieces that could help us to reach this goal. In the economic and social benefits, will be the faster robot product for the customers. So in some part, some companies takes like 1 day to give the product to the customer, but now having more inventory, it could be like in less time. Also, that will be the business performance. So mostly increase the sales and the inventory to the company.
For our general objective, we have the implementation of a flexible manufacturing system in the PVC pipe manufacturing process. So we can reduce the downtime of the system at the time of changing the molds of the heads responsibility for measuring the diameters of PVC pipes, and thus increase the productivity of the production. In the specific objectives, there are 4 of these. The first one is analyze the process of mold change in the manufacturing of PVC pipes. The second is identify the mold change time of the PVC pipe head when doing manually. And the third is reducing the head changeover time at least 30% in PVC pipe manufacturing for increasing the production and the cost reduction. And the last one is decrease the number of personnel in charge of changing the head mold and thus reduce the risks of workers in the process. Our beneficiary will be the company in charge of the production and distribution of pipes on which this project will be based is Plastigama Waving Ecuador. It has a high range of products focusing on the transport of drinking water and sewage.
For the primary research section is was decided to conduct an interview with a worker from the Plastigama company, in which it is so to learn a little more about him and the process used by the company for the manufacturing of tube. The result obtained from this were analysis by means of 2 methods. The empathy method, I can be conclude the most important aspect for the company are to increase production and look for ways to save capital without affecting the quality of the product in order to meet market demand. And next. And the user experience map, here can be observed several important points. For the workers, the transfers of moderate crane and material heating are process with which they do not feel comfortable. Next. For the quantity research, we have extrusion processing consists of heating the material to mold into orifice, and in the manufacturing of pipe of different size and made, which are given by the head. And for the quality research, we have more than 1,000 small diameter pipes per hour. Well, this process involves serious steps for this elaboration. From the entry, the raw material to the store process, raw material to store process. The first step begins with the review and inspection of the raw material for use. The raw material, once the raw material has been inspected, where the material is extruded, become sanded, water cooling bath, the pulling assembly, process station, and putting unit. Okay, next.
In the theoretical framework, in this part, we use the brainstorming and the force relationship to generate ideas to solve the problem. Later, with the impact difficulty matrix, we select the better idea and we finalize making a low resolution prototype of the idea that we select. For the brainstorming, here's the method that where we propose several ideas that can be grouped in the some branches with the same purpose, of which the last ideas in the branch will be the most relevant, resulting in 3 of these being chosen, which are the following: the automated head that by means of an internal control and programming change the side of the tubes. Another one is the robotic arm that can separate the machine head. And the last one is the implementation of pneumatic cylinders and coils, with which it is expected to make automatic change of the molds.
So now we have the 4 relationships. In here, we established 2 different topics that will be the control and programming and the robotic arms. So based on those topics, we set different characteristics. So with the control programming, it says that we have the behavior of multiple devices loop, the faster that they're reading and analyzing the different results. Programming makes sense, like huge amounts of data to check how is improving or not the new systems and devices that can be established with great precision. So these topics are like in general the control and programming, and also for the robotic arms, we have like different movements in access, degrees of freedom, and mechanics, electronics, and control. The transportation from one point to another, to the facilities heavy works performed by humans, and also the increases in production that can be operated. So as I said before, these are general topics that will give us ideas to join them and check if these ideas follows some points about our project. So what is known about the problem in here is the human employees carry out the head changes with large cranes for transportation. So they like, as before, take like more than 30 minutes to do these changes. So this is one kind of the problem, that they like stop the operations to change, for example, from 3 inches diameter pipe to 4 inches diameter pipe. Also the low production downtime while the hand chains are made, the minor production output due to lack of automation. So they still using manual for all the parts. So they have like so many operators to do this job. In this part, we saw that the ideas that could be like joined are the controls or directs the behavior of multiple loops, facility heavy work, a loop products, and devices in precision.
For the impact difficult matrix, it can be concluded the most important aspect for the company are to increment production and look the way to save capital without affecting to quality to production in order to meet market demand. This is how is the most important and less difficult section once you choose the implement of control multiple behaving device programming with feedback to reduce handle change over error. Next.
Finally, for the low resolution prototype, we established like different states, saying like if the manufacturing like the following process for all the system. If the quantity of the diameter pipe is correct, if the production is okay, or if it has to be changed. So it like make a retroalimentation before changing the heads. Also, we have the economic analysis. We're going to talk about the price analysis, social analysis, financial economic study, the OPEX and CAPEX about the project, and the cash flow. For the price analysis, this will be about specific for Plastic Garment company, and it is about the improvement of the production, the setup time, if it will be reduced in the machine, the speed of operations, and the reduce of expenses in this part. For the social analysis, we focus more on what will be the benefits for our clients. And actually, we saw that the national market will increase and have more variety. So many companies will need about these pipes. So they're going to use it. The country increase economically and more jobs will also be open. For financial study, we have about how will be the cost for the new machine and how will be the maintenance for this. And for the economic analysis will be if our product will have the same price and the output, or if this will change or not.
For the OPEX, we have machinery maintenance, operator, government taxes, and public service. For the CAPEX, we have rotatory heads, assembly tools, and installation techniques. Next. Well, here is the cash flow without depreciation, giving about 314,000 without depreciation and 346,000 with depreciation.
In the financial study, for this study, we have to use the cash flow that we calculate yearly. And with that, we can obtain the results for the NBP and the tier. Next, please. From which it is possible to deduce that it is feasible to be able to make the current investment, given that there is a tier higher than the TIO, which means that the internal rate of return is higher than the ones of opportunities. In addition, the project value of the NPV is $681,314 with 71 cents, which as present value has better profit for future earnings. In this last part, the return of investment is calculated, obtaining a term of approximately, next please, approximately 2 years and 1 month. From that point, the company starts to generate profits obtaining from the investment. But we have to consider that the value of money changes over time due to the global market. This means that the amount of money X will now be worth the same, not be worth the same in 5 years. So making this factor into account, now we have the better result of the investment in 2 years and 5 months.
Well, for the high resolution prototype, 2 different processes we perform. One with automatic head and other with manual head to compare the 2 methods. Next. Well, in this moment, present the simulation. And this is the result. Okay, well, is this simulation with manual head manual and automatic manual? When in this you can see the quantity is the manual head and quantity the automatic head. Thanks. Las preguntas. For the conclusion.
Yeah, for the conclusion.
Yeah,
go ahead.
For the conclusion, for the new system, so operation will not be required to change the heads. Instead, they will only be a few operators to control the automatic head. And the time for the automatic set obtain an improvement of the 55% with the implement of the rotating machine.
Good morning, everyone. Today we have the presentation of the group number 10 with the topic implementation of a flexible manufacturing system at Andes Cables. Now you can start your presentation.
Good afternoon, everyone. We are group number 10, and we are going to present our factory project. So in these parts, we have the section with the name definition. Then where we have the description. Our company name is Andes Cables. This is an Ecuadorian company whose factory is located in the city of Santo Domingo. It is dedicated to the manufacture of different types of cables, which means that its production is divided into different lines in certain stages. The main ones being the production are area and warehouse, where there are problems in the distribution of the space and the proper locations of machines, which in many cases hinders mobility within the area. And in addition, due to the large amount of product obtained at the end of manufacturing process, it caused a collapse in the storage facilities, filling the area without having or following an adequate order. For these reasons, we seek to analyze the production process and storage management, where with the use of a flexible manufacturing system to reduce downtime and improve the way in which storage is performed. For other hand, the justification and this project will be carried out in such as a way that the company's production can be increased in its production lines and the quality of its products, focus attention of the problems that Andes Cables keeps present in its production and storage line. It will be possible to develop a restructuring of the management of workstations and personnel, reducing the delivery time between each station and the lost productions that are not properly stored. In this way, a flexible system will be obtained that adapts to the needs without losing or reducing the productions of the plant. We have objectives. The first, realize and take advantage of the manual work of operators and in the breeding and packing area. Other is the automate the picking and packaging process, simulate the flexible manufacturing system in the picking and packing stage, and finally increase 10% of daily production. Primary investigation, Andes Cables contributes to the development of the productive sector and contributes to the dynamics of the regional economy, delivering products that comply with international and national standards such as UL, RTI, ISO, and INE, making the most of its resource while maintaining its high quality and prioritizing the environment. It has been in the market for 12 years, and in the production of they specialize in the production of the THW flexible cables, twin SPT, concentric ST, TTU, and others. Secondary research, electrical cables are the main means of energy transmissions from an electrical source to various devices that require it to operate. So there are many companies that manufacture them in various presentations, characteristics, caliber, and materials. The manufacturing of electrical cables is divided into the following stage. First, there is the wire drawing process, which consists of gradually reducing the diameter of the copper wire until the suitable diameter is obtained, depending on the application. The next process of the cable manufacturing is insulations, where the conductor is coated with an insulator to prevent current leakage. And then we have the phase wiring process, which in brief features consists of grouping different insulated conductors to form a multipolar cable. Finally, there are other sites and quality control process where an outer polymeric coating is added as protection. The methodology is similarly, but for the proper analysis of the information collected, three innovation techniques have been implemented. According to the user experience map, the stage that have more difficulties are the straightening stage, because this activity, despite having machines, depends on the operators for productions to continue. PVC transportations, because PVC is stored outside the production area, generating difficulties when required packing and palletizing, because this process also depends on operators and depends on their capacity to avoid generating bottlenecks. Regarding the empathy map, we have that among the different improvement plans that have been applied to improve the productions of cable manufacturing, many have been successful or have given a satisfactory results. But even so, there are parts of the process where there have been difficulties to improve, as is the case of braiding stage and the baking stage. Sorry. And to consider the impact of our ideas, applied the impact difficulty matrix tool, and basically the ideas of solutions that we take into account are the high values ideas, is that these have high impact, that in our scenario, the implementation of a robotic arm to automatization the preparation of the cable reel, since it directly helps with the problem of Andes cables with the operators. It does not consume many resources. It provides considerably higher profits by having greater efficiency and speed in the packaging and sealing process.
John, por si acaso estabas muteado.
From process map of the company, as we can see, the process is divided into 3 stages. First, the branding stage, where the CCA, that is raw material, is braided, and later is obtaining our braided gowns. The second stage is the extrusion, where where is applied the insolution for the cable. And the third stage is the picking and packing stage, where we did the process of packing for obtain the final product that we can observe, and this is stake on pallets and then transport to a warehouse. Proposal. For the proposal involves replacing the operator by a robot in the picking and packing stage, as we can see. For this, purpose, we implemented our robot-centric layout, as shown in the image. that involve automatic pick up machine, the strapping machine, the filling machine, and the labels. Proposal simulation. For our proposal, we need to validate this. For this is simulated comparing it with the current process. The simulation of the process is carried out for 24 hours, in which the following results are obtained. The process with the operator reached a total of 937 cover rolls, and the process with the robot QR Quantec Ultra a total of 1,062 cover rolls. This is equivalent to an increase in production of approximately 13%.
Okay, about economic analysis, next slide, please. Regarding the fixed and variable costs, we have fixed costs like energy consumption, equipment maintenance, rental of the shed where the plant is located, and variable costs like raw materials, the operators, and the distribution. Next one, please. About revenue projections, for the implementation of the project, an investment of approximately $28,000 is required. However, this will generate a better performance in daily production, achieving an extra 1,125 rolls per day compared to the current production, which generates weekly income of approximately $31,062.50. However, this is not the profit, since several costs of raw materials and other production costs must be subtracted from it. Even so, the return of investment is estimated at approximately 2 years. Next one, please. Okay, about the financial study, we defined the OPEX, the robot preventive maintenance, robot energy consumption, annual licenses to operate the robot, and the cloud services. And the CAPEX, like QR Quantec Ultra, robot acquisition, and the training of the personnel for the current robot supervision. Next one, please. Regarding the cash flow, we obtained 119,467 for the operator. This is without depreciation. For the robot with depreciation, we obtained 136,070, and without depreciation, we obtained $135,405. Next one, please. Okay, we have these results. In the investment value, we need has $28,000, and the rescue value is 1,400. The useful life we define in 10 years, and taxes are 25%. Annual profit is $50,938, and the TO is 10%, and the depreciation is $2,660. Next one, please. Okay, using this data obtained above and the respective formulas, we obtain the NPV. This is equal to $69,929, and ERR equal to 156.26%. Okay, next one, please. Regarding the payback, we use the formulas and obtain that the return of investment is 1 year and 9 months. But taking account, next one, please. But taking account the inflation caused by the depreciation of the currency, the discounted payback is equal approximately 2 years and about 10 days. About the NPV, we have
positive NPV log, that means that is good for the project, and the ERR we have greater than TO. That means that is the project is competitive. Next one, please. About conclusions, we have that at the end of 24 hours, the number of rows already packaged is higher for the production line in which the robot arms work, increasing the production by approximately 13%. It is another one is possible to relieve the operator from this position so that he can perform other activities without the production line. And the last one is analysis was carried out to identify the benefits of Andescables, finding the ERR and NPV respectively of 56.26% and the respectively ERR in dollars, being that the return on investment occurs in approximately 2 years and 10 days. Therefore, this data show that the project is profitable. Thank you.
Como se observa, as we can see, this is the comparison process with QR Quantic Ultra and the process with operator. Results are as shown before that we obtained 1062 at the end of 24 hours of simulation, and the process week operator is 937 units. Also, we can see that average stay time in process with robot are is lower than the average stay time with the operator process. It's the simulation, that's it.
Good morning, everyone. Today we have the presentation of the group number 19 with the topic manufacture of plastic bottles. And now you can start your presentation.
Hi, everyone. My name is Hugo Avilés, and together with my colleagues Carlos Merchan and Yelin Berjurado, we are going to present the manufacture of plastic bottles project. Okay, despite the problems surrounding plastic, this industry has grown in recent years in Ecuador, currently having around 600 companies dedicated to the production of materials with plastic. The sector produces around 500 tons of materials, supplying the food, automobile, commercial, agriculture, and hygiene industry, among others. This represents a sales volume of 1,200 millions, 1.5 1.2% of the national GDP and generates around 140 direct and indirect jobs. Okay, next. However, in Ecuador, there is a problem that many of plastics are not recycled, and it is thought that more people enter this recycling business. But there are the following problems for a small producer, which are the need for a large storage of materials, the need for a large number of operators for each process, and lack of knowledge. Next, to solve this problem, the following objectives has been planted in the recycling plant. Improve the manufacturing process of plastic bottles, reducing their processing time to avoid bottleneck in the plant warehouses, have a profit on the investment within a period of no more than 5 years, and produce 25% more of plastic bottles in our workday than traditional process. Next. Okay, the following people have been consulted about the recycling process. Plant supervisor, worried about bottleneck. The operators hope not to suffer any accidents while carrying out the recycling process. And finally, the plant owner, who expects to ground production, save money, and to be competitive. Okay, next. Okay, the secondary research. We have the process. We have also consulted about the process. First, we have the PET material, which we are going to pass to the injection machine and obtain some small tubes, which will be pre-heating and put it in the molds. To later, with the following method, give it the shape of the ball of the mold, and thus get the final product, a plastic bottle. Okay, next. The process solution will be as follows. The material will be checked and any imperfection in the produce will be stored separately. And if the product is found to be good, the process will continue until the final product is complete. It will be important to have enough machines to avoid the bottleneck, and the material will be transported by conveyor belts. Okay, next.
Okay, so for the solution, we consider the following machines that are also mentioned for the flowchart. So first we have the PET preform injection molding machine that costs around 19,000, and here at the right are its characteristics. Then we have the blower, and here this comes as one. So for each machine we can blow or temp two bottles, and for the heater around 72 pieces. And all of this machine costs $5,700. Next, we also consider two types of blowing molds and like extra molds that cost each one around $6,000. And something that we need to consider is that for the injection machine, also we need the mold. For the implementation in Tuxin, we consider that this machine with the mold, and based on its capacity, we have like 12 cavity or like 12 performs. Next, here we have like the implementation. We have the injection machine with the specific characteristic, and the two more blower machines with its respective molds.
Okay, I'm going to talk about the simulation. So before, first we have the factory before the change were made, which only produce up to 144 bottles in total. In this case, an old injection machine was replaced by a new one, and 2 new blowers were added to give more variety to the factory. Next, please. Continuation, we have the video simulation for our plant of flexing. As you can see, we have the injection machine that was added, where the pellet is divided into 9 small bottles, where they will be given the desired shape later in the blower. Here, we add 2 more blowers to have more variety of the product. There are 2 quality controls at the monitor, the bottles that are timed before and after the blower and the header. And finally, an operator separates the bottle by type. We're up to 12 bottles per pack are storage for later transport by a transporter to the rack. Okay, the simulation. Okay. The results showed that a total of 2,004 bottles have been generated at the end of an 8-hour working day. Individually, we have 57 type 1 bottles, 52 of the type 2, 52 of the type 3 also, and 63 of type 4. Next. About the economic analysis, we have 2 types, the private analysis and the social analysis. The private analysis, we have the benefits of the investor, sorry. It has a good approval in society, raw materials is economic, and it has tax benefits. And the social analysis, the plastic waste is put to use helping to reduce pollution, prevents landfills from burning plastic, and better economic benefits for recyclers. Next.
In the financial economic analysis for OPEX, we consider like the PET pellets that will be our raw material, the electric power, the maintenance, and operators. And for the CAPEX, all of these machines, the blowing, the heater, we also have a mixer, the storage, injection molds, and so on. For our cost effectiveness, we consider here the unit price for the final product, in this case plastic bottles, and the unit price of the pellets. So because the company also can sell the pellets to other manufacturers. So for the projection is for 5 years, and the payback rate is going to be in 3 years and 7 months. We consider our project competitive because the tier we obtain is 11.81%, a little bit higher than the tier considered for the project. And so in conclusion, with this implementation, we achieve 25% more production at the end in a day of work. Also, the project is profitable in a projection of 5 years. And we also implemented our flexible manufacturing plant in assimilation and flexing. Thank you.